Hello everyone, welcome to Columbus McKinnon's Magnatech facility here in Menominee Falls, Wisconsin. I'm Casey Cummins and I'm the Controls Product Manager here at Magnatech, overseeing our drives and drives technology. Today I want to demonstrate for you one of our most exciting safety features called sway control. A sway control is a feature that's built in to our impulse AC drives, and it applies to the bridge and trolley motion of your typical overhead crane. And what it does is it counteracts the load swing that occurs while traversing a load. Load swing is a natural consequence of an overhead crane caused by the load's inertia. The load will continue to swing back and forth, which of course is unsafe due to risk of a collision. Now, if a collision doesn't lead to harm or damage, impatience might. If the operator gets impatient, they may put their body on the line to stop the load. Never do that, and an operator shouldn't even be put in that position. Luckily, these can all be solved with sway control technology. In this demo, the bridge is running at full speed and the operator lets off the run command at the green stripe. Notice a considerable difference in swing during a simple deceleration. Here's the same run with sway control turned on, but with the hoist raised several feet. The conclusion here is that even without hook height feedback, you'll still see a significant reduction in swing at any hook height. Here we're rounding a bend and the load swing is unpredictable, making a precision move difficult and dangerous. Simply turning sway control on eliminates that outward swing and overshoot, making load placement significantly easier and more predictable. Here's a different angle. Notice how smooth the movement is with sway control when running the bridge and trolley at the same time. Placing a load is seamless. Without sway control, the pendulum and inertia becomes your enemy. It swings wildly for what seems like an eternity until the operator gets impatient. Again, don't do that. Use sway control. Setting up sway control is extremely easy, and it really comes down to 3 steps. First step is determining your hook height. So on your hoist, your hook height is the distance from the center of the gravity of the load you're picking to your drum. Now there's a few different ways you can set that up. The first way is if you feed your sway control drives with your hook height from your hoist, it'll dynamically change the hook height as it raises and lowers based on that encoder feedback and feed the algorithm. The second way is just by statically programming a hook height into the drive, and that'll be where sway control works best. There's a few ways of doing that. The first way, you can measure from your load to your drum, or what I like is a more reliable way, is using the pendulum of a hoist and an algorithm. So what I'm going to demonstrate here is we're going to measure the time it takes for our load to swing back and forth 10 times. With that, we're going to divide that by 10 to get our average time for one swing, and then we're going to plug that into the equation shown here. And 10. One of the common myths with sway control is that mass that you're lifting has an impact on the swing. Actually, that's not true. Mass has no factor whatsoever. If you remember the equation that was listed above my shoulder, there wasn't a variable for mass. So I'm going to prove that out now. I changed out the weight to a much smaller weight, and I evened out where the center of gravity is between the two. So I'm going to redo our 10 pendulum swing test, and the time is going to be exactly the same. It's at 10. Now that we have the hook height set up, let's go on to the next 2 steps. So step 2 is determining how aggressively you want the drive to try to accelerate or decelerate. Now this is a little different than if sway control is off or you don't have sway control. You usually would program an actual time into your drive, for example 2 seconds, and that's how long it'll take from 0 to full speed, or full speed to 0. With sway control, it's a little different. You program on an aggressive scale. So the reason behind that is because your acceleration and deceleration is actually different at different hook heights. So your last step is your easiest step, and that's determining how you want sway control to be turned on. It can either be always on, which is going to be in the case of the demonstration I have here. You could turn it on with the flip of a switch. So if you had a radio or pendant that had a switch on it for on-off, you could assign sway control to it. Thanks for joining us today for a demonstration of our sway control technology. As you can see, it makes a significant difference in minimizing your load sway on your bridge and trolley motions, leading to a sharp increase of your productivity, uptime, and safety. If you'd like to learn more about sway control technology, visit us on our website at columbusmckinnon.com/sway control.